Welcome to today's Explainer. Have you ever looked up at a massive commercial complex or maybe a huge industrial facility, or honestly, even just your own house and wondered, what exactly is keeping all of this from just sinking right into the dirt? We're always marveling at the architecture, right? The interior design, the fancy exterior finishes, but we completely ignore the most vital component of the whole shebang. Today, we're going to explore this crucial yet totally invisible structural hero right beneath our feet, the concrete foundation. It's the high-stakes engineering that literally protects every single dollar invested in a property.
So I want you to really think about this for a second. What is the absolute most critical part of any building? Is it the roof keeping the rain out? Maybe the walls providing the structure? Well, actually, scratch that. It's none of the above. Literally, every wall, column, slab, and roof system depends entirely on one single thing for its long-term stability. If this one element fails, the entire structure is compromised, period. We're talking about the barrier between your valuable property and the completely unpredictable earth it sits on.
Okay, let's dive into this. A concrete foundation isn't just, a bunch of cement poured into a random hole in the ground. Not at all. It's a specially engineered structural base. Its number one job, to support a building and safely transfer its massive weight directly into the ground. It essentially takes all that downward pressure from the structure and spreads it out over the soil. This provides the stability needed to prevent disastrous movement, cracking, or just outright catastrophic structural failure as the years go by.
Here is our roadmap for today's Explainer. 1. The invisible structural hero. 2. Choosing the right foundation. 3. Battling the elements. 4. The 4 construction steps. And 5. Warning signs of failure.
Section 1. The invisible structural hero.
We really need to stop thinking of a foundation as just static dirt and hardened cement. It's an active, working defender of a property's value. It is constantly working 24 hours a day, 7 days a week, pushing back against massive forces of nature just to keep a building perfectly upright. Because, let's face it, a building is only as strong as what's beneath it. So the foundation has 2 core responsibilities. The first is supporting the structural load. That means holding up literally everything: the walls, the floors, the roofing, heavy equipment, and every single person inside. It has to distribute all of that weight perfectly evenly so things don't just concentrate in one spot and start sinking. The second big job is resisting ground movement. The earth is not perfectly still, right? A foundation constantly fights against soil expansion, shifting moisture levels, and settling earth. These 2 jobs, working in perfect harmony, are exactly what prevent catastrophic structural failure.
Section 2. Choosing the right foundations.
Now, because the load of a building and the condition of the soil can vary so wildly from project to project, there just isn't a one-size-fits-all solution here. Engineers have this whole arsenal of different foundation types they can deploy based on the specific threats they're facing. Now, what's really interesting about this is the stark contrast between the 2 most common residential and light commercial options. First up, we have slab on grade. This is exactly what it sounds like: a thick concrete slab poured directly right onto properly prepared soil, usually reinforced with rebar or post-tensioned cables. It's super cost-effective and works beautifully if you've got stable soil. But what if the surface soil is unstable or the building needs elevation? Well, that's when engineers switch to the pier and beam system. This involves driving vertical concrete piers deep down into stable soil strata way below the surface, and then connecting them with beams to hold the building up. It provides incredible stability when that top layer of dirt just cannot be trusted.
But what happens when the buildings get bigger? The scale of a building completely changes the complexity and the reinforcements of the engineering. For residential homes with light loads, a simple slab on grade with some rebar usually does the trick. Simple enough, right? But step it up to commercial buildings, think retail spaces or office complexes, and you suddenly need continuous footings and stem walls to handle those moderate loads and distribute that weight across a much broader area. And then there's the industrial level. We are talking massive warehouses, oil field facilities, heavy machinery, the big stuff. Here, you absolutely need heavily engineered, reinforced mat foundations. These are massive slabs designed to withstand extreme downward pressure and the constant vibration of heavy vehicles. Basically, the heavier the threat, the bigger our hidden hero needs to be.
Section 3. Battling the elements.
And this brilliantly illustrates the environmental villains this hidden hero constantly fights, especially in hostile climates like West Texas, where the environment is just incredibly aggressive to structural integrity. First up on the threat list, you've got expansive clay soils. When clay gets wet, it swells up like a sponge, creating immense upward pressure. But when it dries out during a drought, it shrinks, completely removing support and pulling away from the concrete. It is a constant, brutal cycle of pushing and pulling. Second threat, extreme temperature swings. High heat accelerates moisture evaporation, which can rapidly dry out concrete and severely weaken it if it isn't managed properly. And third, intense storm events. Even in really dry climates, a sudden intense rainfall causes rapid runoff. That leads to erosion that can literally wash away the very soil supporting the foundation. Wild, right?
Section 4. The 4 construction steps. So how do we actually build a foundation capable of fighting off all these crazy threats? Let's transition to the actual battlefield and examine the highly structured, exacting process of building this structural base from the dirt up. It's really a cohesive story of engineering, and believe it or not, it starts way before a single drop of concrete is even poured. Step 1 is site evaluation and soil testing. Geotechnical testing determines the moisture content and expansion potential of the soil. Then we move to Step 2, excavation and subgrade preparation. Contractors have to remove organic material and heavily compact that dirt. If you don't compact the subgrade, well, even the strongest concrete is going to settle unevenly. Step 3 is formwork and reinforcement. This is where steel rebar or post-tension cables are placed according to highly precise engineered plans. This gives the concrete its bending strength. And finally, Step 4, concrete placement and curing. The pour itself has to be perfect, obviously, but more importantly, the curing process must be tightly controlled. If concrete loses moisture too rapidly in the blazing heat, it loses its long-term strength. Every single step relies entirely on the one right before it.
So the crucial point is this: a building is only as strong as the foundation beneath it. If a contractor decides, hey, let's rush the subgrade compaction to save a day of labor, or they ignore proper moisture management during the curing process, the results are absolutely disastrous. Cutting corners during preparation or curing inevitably leads to shifting foundations. And let me tell you, when a foundation shifts, you aren't just looking at structural safety concerns. You are looking at incredibly costly, massively complex repairs that will directly drain your wallet and just plummet your property value. Not good.
Section 5. Warning signs of failure. All right, we've talked about the engineering and the construction, but now I want to tell you exactly what battle scars you should be looking for in your own home or commercial properties. This is how you know if your foundation is losing its fight against the earth. If you see any of these structural red flags, you need to act with urgency. On the inside, look for cracked drywall, especially gaps between walls and ceilings, or floors that suddenly start sloping. Notice if your doors and windows suddenly start sticking and won't close properly. Yeah, that means the frame of the house is warping. On the outside, be on the lookout for stair-step cracks in your exterior brick or masonry, visible cracks directly on the slab itself, or any separation at the expansion joints. And please pay very close attention to drainage problems near the perimeter. Water pooling against your building is a guaranteed recipe for accelerated foundation deterioration. Spotting these things early can literally be the difference between a minor repair bill and a total structural overhaul.
50 years. That is exactly how long a high-quality, properly designed, and properly installed concrete foundation should easily last. In fact, if the concrete contractor did their job right, didn't cut corners, tested the soil properly, used adequate reinforcement, and managed the drainage, a great foundation will last the entire lifetime of the structure sitting on top of it. It's a one-time investment that protects a property for generations.
Which leaves us with this final thought to reflect on. Is your foundation built to last decades, or is it already shifting right beneath your feet? The next time you walk into a building, take a quick second to appreciate that invisible structural hero working tirelessly below ground to keep everything perfectly in place. Thank you so much for joining me on this explainer. And hey, keep your eyes open for those warning signs.